Hello everyone! Lately I started a series on basic component types that you can use for your synthesizer DIY projects. In my last video I had a closer look on capacitors, which types there are and how you can read the markings on them. Today I'm going to take a closer look at resistors, why do we need them and how you can read the colored markings on them. Alright, let's get started. Alright, let's take a closer look at resistors. So for my DIY projects I usually use these through-hole resistors here. So they come in these belts and also in different sizes. I think this here is 0 to 0.7. So yeah, of course there are also types for surface mount and so on. I guess most of what I'm going to tell you here today applies for all resistors, but later on I'm going to focus here on the markings for the through-hole resistors here. So what we can use resistors for is current limiting. So for example, if you want to drive a simple LED, for example, which looks something like this. So this needs something like 20 milliamperes, and so if you want to drive this with a power supply, for example with plus 12 volts, this would usually supply much more than these 20 milliamperes. So this means if you connect this directly to the power supply, this will just burn through. And so this means you add a resistor here, resistor R, and this will limit the current that is flowing here. So now we need to find out how big this R needs to be. So there's a simple formula as U equals R times E. So U is the voltage, R is the resistance, we had this before here, and E is the current. So what we are looking for is R. So R would be U divided by E. So, so this is very simple here. So in this case R would be 12 volts times, and so we need the base unit here, so this would be 0.02 amps. And what we get out of here would be 600 ohms, so if we divide that. So usually you would, so there's these resistor tables basically, which hold a certain set of resistors in it. So you would usually search for the next bigger value here. So I guess this would be, I don't know, 680 ohms or something, or maybe something even bigger. So so what I usually do is, for example, if I want to drive LED as an indicator and a power supply, I would use a 1K resistor, for example, to drive the LED, and then I'm pretty much on the safe side. So if you want to have it brighter, then of course you can also choose a smaller value. So this would be one application for resistors. Another one would be you can use it to divide current or voltages. So if you have a setup like this, for example, you have two resistors here, and here is our 12 volts, and here's ground. So and this are two resistors here, and for example, if you have the case that those resistors equal, then this would equally divide current and voltage here. So what you would have here is here you would have 6 volts, for example, if the resistors here equal. So this could be, so if you not need a lot of current here in this place, so this is something where you can easily get some voltage down, for example. So I guess you won't use this as a power supply because I guess so the input here needs to be very stable to know what you get out here. and you also will lose a lot of current here. So if you need to drive some current here, you will lose a lot of current here. Yeah, so as I said, so this depends here on the proportions of the resistors that you are using here, and yeah. For example, you could also use this. So if you not need a lot of current here, for example, if you have an op-amp here, op-amp buffer, for example, something like this. This, for example, would be an application in a synthesizer. You will want just to get some voltage down, and you're not driving a lot of current, and then you can do something like this here, for example. So in this case, you would choose big values here for R, so there's not a lot of current. You're not losing a lot of current here. So let's take a look at the color codes here. What I'm usually using is these resistors with 5 color bands. So depending on the precision, there are 4 or 5 colors. So I'm using these with more precision. So this precision is 1%. So this usually works for all my applications, and I guess the price it makes no difference. So there's no excuse to not buy these 1% resistors, I guess. So, and it's actually not that hard. So you have different colors here. You can see this here in the example in this chart here. So you have different colors which stand for a different number, basically. So this would be the first 3 colors would stand for a certain number, and there comes a multiplier here. So, for example, if you have something in the 100 range, then the fourth color here would be orange. If you have something in the tens, then this would be 100 ohms, and so on. The next color here is the tolerance. So usually this is brown for the resistors I have, so this is 1%. And then there's also like how they tolerate temperature changes, but that's not important here, I guess. So, for example, if you would have like 100K resistor, so then this would look something like this here. So this would be a 1, a 0, a 0. So this is brown, black, black. This is 100 times 1K. So this would be an orange here, and this would be our 100K. So in reality, this would look something like this here. So brown, black, black, orange, and then here the tolerance, which is brown in this case. So this would be another example here. So this is a 4.7K resistor. So this starts with yellow here. So this is for 4, maybe a bit hard to see here. So this is violet here for 7. Then there's a 0, black, and then there's brown, so 10. So this would be 470 times 10 is 4,700 ohms, would be 4.7 kilo ohms. So, and basically this works the same all over. Yeah, so sometimes it's hard to see the difference here, for example, between yellow and white, or orange and red. Sometimes it's a bit hard to see. So what you always could do is, of course, just get your multimeter out and measure it through. Put it on measuring ohm and put it on here. So it's that simple, and you can see they're pretty precise here. So this is within the 1% tolerance for sure. What do I have here? Some other example here. So I guess this is 1 mega ohm resistor here, for example, and this is the 100K we had before. Yeah. So It's that simple. So for the four-band resistors, this, basically the same principle would apply. So this is basically completely the same. Then you won't have this here. So this will be left out. Basically this row here, and this will be basically shifted here, the color by one. So this is, but it's basically the same. So it's the same principle. Maybe one more addition, so there are websites where you can basically dial in the color codes if you're not sure in the beginning, and then it's very easy to find out actually. So I'm going to link something in the description below. Take a look at it. And when I was a kid, I actually had some dial made out of paper, where you can dial in resistor values, and then you had the value at the bottom. But I'm not sure if those exist anymore. All right. I guess it's all for today. So if you're into building your own synthesizers, make sure to check out my online store. So there are all sorts of DIY kits that get you started. All right. Thanks for watching. See you next time, and bye for now.